All right, ready to dive into some interview prep.
Sounds good. Let's do it.
Today we're tackling the Optoelectronic Engineering Technician interview. And we've got these awesome guides from RoleCatcher. They're packed with insights and sample questions to help you, totally rock this interview.
Yeah, these guides are great. They even have this AI-powered feedback thing to tailor your answers to specific job roles. It's really cool.
Exactly. And let's be real, the world of optoelectronics, it's exploding right now. Lasers, fiber optics, LEDs, all that cool tech shaping the future. But before we get into the nitty-gritty of the interview, I think it'd be helpful to understand what this role actually involves. Paint a picture for everyone.
Okay, so think of it this way. Optoelectronic engineering technicians, they're the hands-on experts, the ones building, testing, calibrating. All the equipment that makes these incredible technologies a reality. They work super closely with engineers, making sure designs, become functional devices. It's a role that needs a mix of technical skills, attention to detail, and a genuine passion for solving, complex problems.
Makes sense. And RoleCatcher's Career Guide, it really stresses the importance of hands-on experience, which, yeah, totally tracks. But what kind of, day-to-day tasks can someone expect in this role?
Let's see, you might be assembling and aligning optical components, maybe testing and troubleshooting laser systems, or even calibrating photodetectors for super precise measurements. It's really dynamic, always learning, adapting to new tech.
Okay, I like it. Now let's talk career path, the possibilities. What can someone look forward to in terms of, growth, advancement, all that good stuff?
Right, so with experience, you can move into supervisory roles, maybe even management, leading teams of technicians. Or, if you're feeling ambitious, pursue further education. Become an engineer yourself, designing the next generation of optoelectronic systems. It's a constantly evolving field, so continuous learning is key to staying ahead.
Staying ahead. That's something RoleCatcher's interview guide, it emphasizes that a lot, showcasing your knowledge of industry trends, even suggesting, mentioning specific areas like LiDAR or silicon photonics to really demonstrate your interest in the future of the field. I thought that was a really cool tip.
Yeah, definitely. It shows you're not just stuck in the present, that you're thinking about the future of the industry. That can really impress interviewers. It shows a proactive mindset, a genuine passion for what's next.
Totally. Okay, let's jump into some of those sample interview questions. And remember, RoleCatcher's AI can give you feedback on your answers, help you tailor them to specific job roles. It's pretty game-changing.
Okay.
So first one, what experience do you have with designing and testing optoelectronic devices? How would you approach that?
All right. So the key here is to be specific and give concrete examples. Don't just say, I have experience. Talk about specific projects you've worked on, the types of devices you've designed and tested, the tools and methodologies you use. Really paint a picture.
Okay, so for instance, I could say, in a previous role, I designed and tested a fiber optic sensor. For a medical imaging device, I used optical design software like Zemax to simulate the sensor's performance. And then I built and tested a prototype using, laser diode, a photodetector, and fiber optic cables. And then I analyzed the test results to make sure the sensor met the required sensitivity and accuracy. Would that be a good approach?
That's a great example. You're giving specific details, showcasing your technical skills and that hands-on experience. They might even ask a follow-up, what challenges did you face during that project? That's your chance to really shine, show off those problem-solving abilities.
Okay, so maybe I could talk about a specific challenge, like dealing with signal noise during testing. I suspected environmental interference, so I shielded the sensor and implemented a digital filtering algorithm to reduce the noise. That would highlight, my ability to identify, analyze, and solve those technical hiccups.
Exactly. It shows you're not just a technician. You're a proactive problem solver, someone who can think critically and find solutions. Because, interviewers, they're looking for candidates who can go beyond just following instructions. They want someone who can spot issues, analyze them, and develop effective solutions.
Got it. Okay, next question. How do you stay current with the latest advancements in optoelectronics technology? This one is all about, that continuous learning, right?
Yeah, for sure. This field is constantly evolving, so staying updated is crucial. Mention those industry publications you read, like Optics Express or Photonics Spectra, or conferences you attend, like SBI Photonics West. Online courses are great too, and professional organizations you're a part of.
So instead of just saying, I read industry journals, I can be more specific, like I subscribe to Optics Express to keep up with the latest research. I also attended SBI Photonics West last year and learned about the advancements in silicon photonics, which is a field I'm really excited about. That way, I'm showing concrete examples and highlighting a specific interest.
Now you're connecting your learning to your interests and potential career goals. It shows you're proactive, passionate about staying ahead. They might even ask you to elaborate. Like, can you tell me more about a specific advancement that you find particularly exciting?
Ooh, that's a good one.
Mm.
How do I choose what to talk about?
Think about what genuinely excites you. For example, if you're fascinated by LiDAR and its potential in, like, autonomous vehicles, you could discuss the latest developments in solid-state LiDAR systems, or the challenges of integrating LiDAR into existing automotive platforms.
So instead of just saying, I'm excited about LiDAR, I could go deeper. Explain a specific aspect and why it interests me. Show a deeper understanding and my ability to, critically think about the future of that technology.
Exactly. It's about going beyond the surface, showcasing your curiosity and your analytical thinking skills. Interviewers, they want candidates who are passionate about this field and eager to contribute to its advancement.
Makes sense. All right, question 3. Can you explain your experience with fiber optic communication systems? Fiber optics, it's such a huge part of optoelectronics. I bet this comes up a lot.
Oh, it definitely does. And it's your chance to showcase your practical experience, highlight specific projects, the types of systems you've worked with, any challenges you've overcome. For example, you could talk about installing and testing a high bandwidth fiber optic network, maybe for a data center, mentioning specific tasks like splicing and terminating those fiber optic cables, or configuring optical transceivers.
Okay, so I could say something like, in a previous project, I was involved in upgrading the fiber optic infrastructure for a large corporation. I worked on installing new fiber optic cables, splicing them to existing cables, and terminating them in patched panels. I also configured the optical transceivers to make sure we had optimal signal transmission. Would that be specific enough?
Yeah, that's a great start. You're giving concrete examples of what you did. But what if they ask, what was the most challenging part of that project? How would you answer?
I could talk about a specific challenge I faced, like troubleshooting signal loss issues. I could describe how I used an optical time domain reflectometer, OTDR, to pinpoint the location of a break in the cable, and then repaired it using a fusion splicer, showing off my troubleshooting skills and my ability to use, specialized equipment.
Perfect. By describing the specific tools and techniques you used, you're showcasing your expertise and your ability to overcome those challenges.
Now, what if they ask about a specific type of fiber optic cable or component? For example, what is your experience with single mode versus multi-mode fiber? How do I explain that in a way that's clear and easy to understand?
Okay, good question. You could start by saying something like, I've worked with both single mode and multi-mode fiber. I understand that single mode fiber, with its smaller core, it's typically used for long-distance, high-bandwidth applications because it minimizes signal dispersion. Multi-mode fiber, on the other hand, has a larger core, and it's more suitable for shorter distances and lower bandwidths because it allows multiple light paths. Like in that data center project I mentioned, we use single-mode fiber to connect buildings across the campus because of the long distances and high bandwidth needs.
So it's important to not only define each type of fiber, but also explain their different uses and why you might choose one over the other in a specific situation.
Exactly. It's about demonstrating your understanding of the nuances of fiber optic technology and how you apply that knowledge in real-world scenarios.
This is great. We've covered a lot already. Before we go any further, I want to remind everyone about RoleCatcher's AI feedback feature. It's seriously amazing. It analyzes your responses and gives you personalized suggestions based on the specific job you're applying for. It's like having, a virtual interview coach in your pocket.
It's a game changer for sure. It takes the guesswork out of prepping, gives you that extra edge.
Okay, let's move on to question 4. How do you troubleshoot and repair optoelectronic systems? This one seems, pretty straightforward. What's the key to really nailing this answer?
It is pretty straightforward, but there's a way to answer this. That'll make you stand out. It's not just about, showing your technical skills. It's about showcasing your systematic approach to problem solving.
Gotcha. So it's not enough to just say, I check the connections and replace faulty parts.
Exactly. Walk them through your process. Start with identifying the symptoms, then, use diagnostic tools like schematics to isolate the issue, and finally, explain how you implement the repair,
Right.
and then verify that everything is working correctly.
Okay, I see what you mean. So I could say something like, my troubleshooting, it always starts with understanding the problem. What are the symptoms? Let's say a laser printer is printing really faintly. First, I'd inspect the optical path, look for any obstructions, misalignments. Next, I'd use a power meter to check the laser diode's output and compare that to the specifications. If the output's low, I'd take a closer look at the laser driver circuit, refer to those schematics, to understand how it all works and pinpoint any potential faulty components. Systematically eliminate possibilities so I can, efficiently find and fix the issue. How does that sound?
That's a great illustration. You're demonstrating a logical approach and your ability to use observation, tools, and documentation to reach a solution.
Awesome. What if they throw a curveball and give you a specific scenario? Like, how would you troubleshoot a loss of signal in a fiber optic link?
That's where your practical experience really shines. Just walk them through your steps, like visually inspecting the cable and the connectors, using an optical power meter to find that loss point. You could even mention advanced techniques, like using an OTDR to pinpoint breaks or bends in the fiber.
So I'd say something like, first, I'd visually inspect the fiber optic cable, look for any obvious damage, loose connections. Then I'd grab an optical power meter and measure the signal strength at various points along the link, starting from the source. By comparing those readings, I can isolate the section where the loss is happening. And if needed, I'd use an OTDR to get a precise location of any faults within the fiber itself, like breaks or sharp bends. Does that sound right?
Spot on. You've shown that you can handle those routine checks and the more advanced techniques, which demonstrates a solid understanding of fiber optics.
Great. Okay, next question. How do you ensure quality control in optoelectronic manufacturing processes? This feels like it goes beyond just technical skills, right?
Absolutely. It's about demonstrating your understanding of quality standards and procedures. It shows that you're meticulous and committed to delivering reliable products.
Should I mention specific methodologies, like Six Sigma or SPC?
It's good to know those, but focus on how you actually apply them. Describe the specific tools you've used, like an optical microscope to inspect those components, or a spectrophotometer to analyze spectral characteristics. And don't forget documentation, making sure everything's traceable and compliant.
Right. So instead of saying, I'm familiar with SPC, I could say, in my previous role, I was responsible for the quality of laser diode modules. I would use an optical microscope to inspect the alignment and bonding of the diode lens and fiber. And it also used a spectrometer to measure the output spectrum and power, make sure it matched those required specifications. And of course, all measurements and observations were carefully documented to maintain traceability and comply with quality standards. That feels a lot more concrete.
Much better. You're painting a picture of your active role in quality control, highlighting those tools and procedures. Now, imagine they ask, tell me about a time you identified a recurring defect. How did you approach the problem?
Perfect opportunity to demonstrate problem-solving skills. In a quality control context, I could share an example where I noticed a pattern of laser diodes with lower than specified output power. I could describe my investigation, maybe tracing it back to a variation in the manufacturing process and how I collaborated with the engineering team to implement corrective actions.
That's a powerful example. It shows you're not just checking boxes. You're actively analyzing data, spotting trends, and collaborating to improve the process. That's incredibly valuable in any manufacturing setting.
All right, next question. How do you ensure the safety of optoelectronic systems during testing and operation? I feel like this one's all about responsibility, right?
It is. Safety is paramount. Especially when you're dealing with lasers, your answer needs to show that you know those safety protocols, those protective measures, and your commitment to a safe working environment for yourself and everyone around you.
So things like wearing laser safety glasses and gloves, following procedures, being aware of laser classifications and power limits, knowing those emergency protocols.
Yes, and don't just list them. Show you understand them. You could say, when I'm working with high-power lasers, I always make sure it's interlocked to prevent unauthorized operation, and I use beam enclosures to minimize any stray reflections. I always ensure everyone nearby is wearing the right laser safety eyewear, and that warning signs are clearly visible. I'm also trained to recognize and respond to potential laser incidents, including knowing how to shut down the system immediately.
That definitely sounds more impactful than just saying I wear safety glasses.
Exactly. You've demonstrated that you're not just aware of the rules, you actively apply them to create a safe working environment.
Okay. Question 6. How do you collaborate with engineers and scientists to develop optoelectronic systems? This feels more about soft skills than technical knowledge.
It is, but it's essential, especially in this field where innovation often relies on collaboration. Highlight your communication skills, your ability to listen and understand complex instructions, and your knack for turning those technical concepts into practical implementations.
So instead of just saying I'm a team player, I could share a specific example, maybe a project where I collaborated with an optical engineer to develop a new fiber optic sensor, and how I provided feedback based on my testing, leading to design improvements. That optimized the sensor's performance.
Perfect illustration. You've shown that you can make valuable contributions to the development process through clear communication and constructive feedback. Now, they might dig a little deeper and ask, tell me about a time you had to communicate a complex technical issue to an engineer who wasn't familiar with the specifics of your work.
Okay, that's a good one. I could share an instance where I had to explain a problem with a fiber optic amplifier to an electrical engineer who wasn't, super familiar with optics. I could talk about how I used analogies and simplified explanations to bridge that knowledge gap, make sure we were both on the same page, to effectively troubleshoot the issue.
That shows adaptability and a collaborative spirit. You're able to adjust your communication style to effectively convey technical information to a diverse audience.
Got it. Question 7. Can you explain your experience with optical design software? I'm guessing this is where I get to show off my software skills.
You got it. Be specific about the software you're comfortable with, like ZMax, CodeV, or anything relevant to the role. But don't just list them. Talk about how you've actually applied them.
Right, so I could say something like, I'm proficient in ZMax. I've used it extensively for designing and simulating optical systems, including lenses, mirrors, fiber optic couplers. For example, I use ZMax to design a custom lens system for a high-resolution imaging application, optimizing things like the focal length and numerical aperture to get that desired image quality.
Excellent way to demonstrate your practical experience. You've gone beyond just naming the software and highlighted how you've used it to solve real-world problems.
Now, what if they get specific and ask about a particular feature or function, like how do you use ray tracing in optical design?
Be ready to explain key concepts. You could say, ray tracing, it's a fundamental technique that simulates the path of light rays as they interact with optical elements. I use it to evaluate image quality, identify aberrations, and optimize my designs to minimize those aberrations.
Okay, I'm seeing a pattern here. It's not enough to just know the terminology. I need to be able to explain it, and even more importantly, show how I've applied it in those real-world scenarios.
Exactly. That's what shows them you're a skilled technician, someone who can hit the ground running.
Makes sense. All right, question 8. How do you ensure the performance of optoelectronic systems in different environmental conditions? This sounds like testing to the extreme.
That's it. Optoelectronics, they often have to work in tough conditions, extreme temperatures, high vibration. The works. Your answer should show that you know about environmental testing procedures and standards, demonstrating your commitment to those robust, reliable designs.
So should I mention specific standards?
Yeah.
Like MIL STD 810 or IEC 6000068?
Definitely. But again, go beyond just name dropping. Describe those tests you've conducted. Temperature cycling, humidity exposure, vibration testing, shock testing, the whole shebang. You can even mention specific equipment like those environmental chambers.
Okay, so I could say I've done environmental tests on various systems, following standards like MIL STD 81010. For example, I used an environmental chamber to put a laser rangefinder through temperature cycling tests to make sure it functioned reliably across its entire operating temperature range.
Great example. You've shown not just awareness of standards, but real experience applying them.
What if they ask about a specific environmental factor, like how does temperature affect the performance of a laser diode?
Be prepared to explain those effects. You could say temperature variations, they can impact a laser diode's threshold current and output power. I've used temperature control mechanisms like thermoelectric coolers to stabilize that performance and ensure consistent operation across different temperatures.
This is fantastic. I feel so much better equipped to tackle these technical questions with those detailed, specific answers. And don't forget, everyone, RoleCatcher's AI feedback. It's like having a personal interview coach right there in your pocket. It can analyze your answers, offer suggestions for improvements, and highlight those key skills to really emphasize for each job. It's a total game changer for anyone prepping for an optoelectronics interview.
Couldn't agree more. It's an invaluable resource to help you fine-tune your responses and make a lasting impression.
Okay. Are you ready for the final round of questions?
Hit me with them. This is where things get really interesting. We can dive deeper into some of those more, nuanced areas of optoelectronics and show off your advanced understanding.
All right, bring it on. Okay, so we're back, ready to tackle those last few interview questions for our aspiring optoelectronic engineering technicians out there.
Let's do this. Get you prepped and ready to land that dream job.
All right, so imagine the interviewer throws this one at you. How would you explain the concept of wavelength division multiplexing to someone, without a technical background? It's like those explain it like I'm 5 moments.
Right. Those can be tricky. The key is to break it down, make it relatable. Analogies can be super helpful here. Think of it like a highway, each wavelength of light. It's like a separate lane, allowing multiple data streams to travel at the same time over a single fiber optic cable.
Got it. So it's like having multiple conversations on the same phone line, but they're each using a different frequency so they don't interfere with each other.
Exactly. That's a great way to put it. Okay, let's switch gears a bit. What if they ask, what are some emerging applications of optoelectronics that you find particularly exciting?
Yes. Time to geek out a little. Show off that passion.
For sure. This is your chance to demonstrate that you're not just knowledgeable, but you're also forward-thinking. You know what's on the horizon. You could talk about silicon photonics, how it's revolutionizing data centers with faster, more efficient data transmission.
Yeah. I was just reading about that, how silicon photonics is being used to create optical interconnects for supercomputers. It's crazy how they're using light to move massive amounts of data at incredible speeds.
See, you're already on top of it, staying current with those advancements. And don't forget about LiDAR. It's not just for self-driving cars anymore. It's being used in archaeology, environmental monitoring, all sorts of things.
I can see that. LiDAR would be amazing for creating 3D maps of ancient ruins or tracking deforestation patterns.
Exactly. You're making those connections, showing a wider understanding of the field's impact. Okay, last question, and it's a big one. What are your salary expectations? This one always makes me nervous. I don't know about you.
Oh, yeah, for sure. It's tricky. How do you approach that strategically?
Do your research. That's number one. Use resources like RoleCatcher's salary guide, websites like Glassdoor. See what similar roles are paying in your area.
So I should have a specific range in mind based on my experience and the job market.
Yeah, but don't be afraid to be flexible. Emphasize that you're more interested in the opportunity itself, the chance to learn and contribute, than a specific number.
Got it. So something like, based on my research and experience, I'm looking for a salary in the range of X to Y. But, I'm definitely open to discussing this further, depending on the specifics of the role and the overall compensation package.
Perfect. You've done your homework, but you're also open to negotiation. Shows you're reasonable and adaptable.
This has been great, really insightful. It's amazing how these seemingly simple interview questions can really reveal a lot about a candidate's, technical knowledge, problem-solving skills, and passion for this field.
Absolutely. And remember, RoleCatcher's AI-powered feedback is there to help you. It can give you personalized insights and suggestions to really refine those answers and help you shine.
It's like having that personal interview coach, analyzing your responses, highlighting areas you can improve.
Exactly. So go into that interview with confidence. You've prepared well. You've got the tools you need to showcase your best self.
It's deep dive into the world of optoelectronic engineering technician interviews. It's been so helpful. I feel much more prepared and excited about the possibilities out there.
And remember, continuous learning is key. This field, it never stops evolving, so stay curious, explore those advancements, keep pushing those boundaries. You never know what you might discover.
To all our listeners out there, good luck with your interviews. Embrace the challenge. Let your passion shine through, and let that knowledge light the way to a fantastic career in this incredible field of optoelectronics.
Best of luck.